Dear student, in this lesson we are going to learn how to draw a Lewis structure. What is Lewis symbol? A convenient way to keep track of the valence electrons in an atom or molecule we call a Lewis structure or Lewis symbol. In Lewis dot symbol or cross symbol we can use here to represent all the valence electrons around chlorine using this kind of symbol, and using cross we can represent the Lewis symbol. Each dot or cross represent one valence electron. In this table you can understand how to draw a Lewis symbol in a particular element. If you know how to write down the electronic configuration, then easily you can understand what are the valence electrons. Then number of valence electrons you can draw around the symbol of element. Then that called Lewis symbol. Then let's understand what is Lewis structure. Here we using this kind of combination of two or more atoms together to form a molecule. We can represent this molecule where the covalent bond form. Here this type of structure we call Lewis cross dot structure. For all cross we can represent using only dots, and also if you can represent bonding electrons as using lines, those type of molecular structure we call the Lewis structure. You can see two examples, lines corresponding to two electrons in bond, and Lewis structure are representation of molecule showing all valence electrons, bonding and non-bonding electrons. Now let's study how to draw a Lewis structure. To draw a Lewis structure you have to follow few steps. The first one is find the sum of valence electrons of all atoms in the polyatomic ion or molecule. Let's take an example, PCl3. Here the number of valence electron in phosphorus is 5 and number of valence electron in chlorine is 7. Therefore the total number of valence electrons are, there are 3 chlorine atoms, therefore 3 into 7 is 21 plus 5 is equal to 26. Then I took all these 26 electron to outside, and if is an anion you have to add 1 electron for each negative charge, and if it is a cation you have to subtract 1 electron for each positive charges. Here this is a neutral molecule, therefore you don't need to add or subtract. Therefore 26 electrons, and I separated out all the chlorine atoms and phosphorus. Then the central atom is the least electronegative element. Here among those 4 atoms, as you know, the phosphorus is the most electropositive element. Therefore you have to keep it in the center. However, when you are selecting electropositive or least electronegative atom, you can't use as hydrogen to central atom, because as you know, around the hydrogen atom you have to keep only 2 electrons. Therefore you can't use hydrogen as a central atom. Then you have to connect the outer atoms to it by single bonds. So then how you can combine those using single bonds? You have to take electrons from the electrons you kept away. Then I will take these two electrons to that side and use a bond, and another two electrons keep into this place and make another bond, and another electrons, two electrons, and put and keep into this place. Now all the atoms are interconnected. As the third step, we have to keep those remaining electrons around the atoms. For that, first we have to put 8 electrons around the outer atoms to fill their octet. For that one, I have to keep those electrons and put 1, 2, 3, 4, 5, 6 electrons, and I put those 6 electrons around this chlorine. And next I have to put all these electrons around this chlorine atoms. Then what happened around this chlorine? There are 8 electrons with these 2 electrons in the bonding electrons. Therefore, totally filled with octet in the chlorine. Then as the next point, we have to keep the remaining electrons in the central atom. For that one, we have only 2 remains. Then we can put these 2 into, put all the valence electrons around those atoms. Now you can stop the writing of Lewis structure. For this example, the Lewis structure is finalized according to the picture. However, sometimes you have to go further to draw a complex Lewis structures. Let's study that kind of structure again. Let's go from the first step to draw the molecule of HCN. In here, for H, there are 1 electrons. For carbon, as you know, there are 4 electrons, and nitrogen, there are 5 electrons. Therefore, altogether number of electrons are 10. Therefore, I will keep those 10 electrons outside and keep those 3 atoms separately, and then keep out the valence electrons. Then let's move to the second step. In the second step, we have to keep the central atom in the least electronegative element. Among these 3, as you know, the least electronegative atom is hydrogen, second is carbon, and third is nitrogen. But we can't keep hydrogen as the central atom, as we know. Therefore, the second option is carbon. Therefore, we have to keep carbon as the central atom. Then I kept 2 electrons to bond this hydrogen and carbon, then another 2 to bond with carbon and nitrogen. Then keep those remaining 6 electrons around the outer atoms. However, we can't keep any electrons around hydrogen because already now 2 electrons near the hydrogen. Therefore, these 6 electrons are keep in the nitrogen atom. Therefore, there are no remaining electrons to keep in the central atom. Now, around the carbon atom, there are only 4 electrons in this 4 bonding electrons only. Therefore, still the central atom not achieve to octet. Therefore, you have to keep multiple bonds until central atom become octet. Then I keep these 2 electrons in between carbon and nitrogen, then it become bonding electrons. Then these 2 also we can keep in between carbon and nitrogen, then we can say it's a bonding electrons. Now therefore we can write down this kind of, using this kind of equation you can represent those changes. Then actually now you can say carbon and nitrogen are also fill their octet. We have to assign the formal charges. First let's see the two Lewis structures we have drawn in previous stage. In the third step we have drawn this structure. Then let's take what are those valence electrons at the beginning in hydrogen, 1, and electrons assigned to atom in the structure now also 1, therefore no formal charge for hydrogen. But in carbon, as you know, the valence electrons around the carbon is 4, but now assigned electrons to carbon is 2, therefore charge of the carbon is +2. And nitrogen, there are 7 electrons around the nitrogen now, but as you know there are only 5 valence electrons, therefore more than 2 electrons are there, then we can assign -2 as the formal charge. Now let's calculate what are the formal charges for the last Lewis structure of HCN. Here hydrogen already have 1, in here this one 2 for this bonding orbital. So this first one is belongs to hydrogen, therefore hydrogen has the formal charge 0. Then for carbon, in this bond 1 is there for carbon and 1 is there for carbon and 3 and 4, therefore carbon have then 4 electrons, and also the valence electrons for carbon is also 4, therefore formal charge is 0. For nitrogen you can say this is 1, 2, 3, 4 and 5 electrons are there assigned to the atom nitrogen, therefore there are 5 now, and valence electrons also 5, therefore the formal charge is 0. For a better Lewis structure you have to keep 2 points. One is you have to keep the fewest charges around atoms, and also if there is a charge, if there is a negative charge, you have to keep those on the most electronegative atom, and there are plus charge we have to keep in the most electropositive atom. That is the best Lewis structure. Now I will take another example to understand more. Example is NO2 minus. For those NO2 minus, nitrogen has 5 valence electrons and oxygen, as you know, has 6 valence electrons. There are 2 oxygen, therefore 2 into 6 plus 5, and also there are negative charge, therefore you have to keep another 1 electrons as the valence electron, therefore totally number is 18 electrons you have to keep in the outside. Now we have to do the second step. For NO2 minus, now you know the total number of electrons are 18, and then the central atom should be nitrogen, because that is the most electropositive atom among these 3 electron atoms, therefore you have to keep nitrogen in the central and oxygen in both sides. And to use 2 electrons and 1 bond another 2 electrons, therefore you have to reduce 4 electrons, therefore you have still 14 electrons remaining to keep those 14 around the outer atom. Let's keep these electrons in the outer atoms, nitrogen, oxygen, oxygen. Now we still have 14 electrons. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, you have to remove 12. Still you have 2. Therefore, we have remaining 2 electrons, then we can keep those 2 electrons on top of nitrogen. Now actually still nitrogen has 1, 2, 3, 4, 5, 6. Therefore, we have to keep bonds because nitrogen not yet complete to octet. Therefore, we can put these 2 electrons into here and we can write down double bond oxygen 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, 6. Then you finish the octet for every atoms. In here actually you can go more than 8 to the central atom if the central atom is in the third row or below in the periodic table. For example, for phosphorus, you can keep more than 8 electrons around the phosphorus when it is in the central atom, because the valence electron filled to this phosphorus is third energy level. In the third energy level, as you know, number of 18 electrons we can keep. Therefore, in the central atom is in the third periodic or the below, then you can keep more than 8 electrons around the central atom. As the fifth step, we have to keep the formal charge for every atoms. Therefore, again I will write down oxygen and oxygen 1, 2, 3, 4, 5, 6. Here 1, 2 and 1, 2, 3, 4. Now this is the structure up to now we have drawn. Therefore, now let's assign the formal charges for this oxygen. As you know, oxygen 6, nitrogen 5 and oxygen 6 is the valence electron should have. But in this first oxygen atom, there are 7 electrons around this oxygen atom. Therefore, 1 excess, therefore the formal charge is -1. But in this nitrogen, there are 5 electrons around this nitrogen, therefore formal charge is 0. Here 6, therefore formal charge is 0. Now then we can draw this structure like this: double bond O, 1, 2, 3, 4, 1, 2, and here oxygen 1, 2, 3, 4, 5, 6. But there are no charge in nitrogen and second oxygen, but you have to keep minus in this oxygen atom. Therefore, this is the structure of NO2 minus. Now you can write down this is the Lewis structure of NO2 minus. About resonance structure. Let's take the previous example. In this example, you have drawn the Lewis structure of NO2 minus, but this oxygen has -1 charge, this oxygen has 0 charge. why this unfair thing take place to one oxygen, other one is negative, one is 0. Can you write down this same compound like this? This is negative, and also you can put oxygen here. Now the left hand side becomes 0 charge and right hand side become negative charge. What is the correct structure among these two? Actually, both are not existing in the nature. However, this kind of reaction take place. What will happen? These two electrons can go to the middle of nitrogen and oxygen, and these two again go to oxygen to form the second structure. In the second structure, you can do the thing other side. For example, this oxygen, 2 electrons can go to middle of nitrogen and oxygen, and again there are 2 electrons remaining. Then this can go to this oxygen to become again the first structure. Therefore, actually these two exist in the both one and second structure, both in the nature. Therefore, we can write down correct structure is like this. And other are both existing both side as the resonance structure. We call this as a resonance structures. Therefore, for this molecule we have 2 resonance structures, first and second. However, the structure existing in both way. We can understand using another way, another example. I will take another example, O3 ozone structure. How you write down? There are 3 oxygen atoms. Therefore, 6 into 3 is 18 electrons are there. Then you have to keep oxygen in the central and other oxygen in the other sides. Therefore, you have to put this one, and then 4 already finish. Now you have 14, then you have to keep those 14 electrons around this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now outer side electrons fill, then you have to keep into the central atom. Now still the octet rule not fill, therefore you can put these 2 into middle, then you can write down like this, oxygen and oxygen, 1, 2, 3, 4, 5, 6, and here the double bond oxygen. Then you have to assign the charges. Here the left hand side has 7 electrons, therefore you have to put -1 charge here, and the central oxygen atom there are 5 electrons only. However, you have to put 6 in the valence, therefore +1 for this oxygen atom. Therefore, this is the correct structure of Lewis structure for ozone. However, this ozone structure we have write down also have 2 resonance structures, as we discussed in the previous example. 3-dimensional structure shape of ozone and the electronic distribution. Then therefore, actually the ozone structure not exist as this type. -1 and +1, or you can write down other way. Oxygen, this is double bond, and 1 2 3 4 2 and 1 2 3 4 5 6, here negative charge and this is positive charge, and this is also come again to other side. Therefore, but according to the real situation, the first structure is not exist and also the second structure is not exist. The equal distribution of these both side double bonds can move always, and the length of both bonds are same. Practice more and draw Lewis structures for the given chemical formulas, and please submit your assignment. Thank you very much for listening.